Hi there. Thank you for joining our webinar today. My name is Kyle Goodrich, an applications engineer here at Snaptron. And here at Snaptron, we've been a leader of tactile metal dome manufacturing for over the last 30 years. And fun fact, we've been doing all of that here in Northern Colorado, our entire history from design to manufacture. So the focus of today's webinar will be to show the different ways to apply dome switches to PCBs, and we'll discuss some of the trade-offs between each method for speed, reliability, and tactile performance. At the end, I'll provide some practical tips on optimizing dome placement for your specific project and assembly. And then at the end, we'll wrap up with a FAQ from the audience. We'll start today's webinar with an overview of each placement method, the pros and cons of each. Then we'll go into a live demonstration of each one. We'll also mention some other more automated placement methods, such as using our SureShot dome placement robot, as well as using pick and place machines for SMT devices. But let's first start off with why dome placement matters in the first place. Proper dome placement really ensures the consistent tactile response of the dome switches in your assembly. It also ensures long-term reliability, consistent electrical performance, and make sure that the dome itself is aligned correctly with the PCB contacts. Poor placement can lead to misaligned or multiple domes in certain locations, which would alter the electrical or tactile performance of the switch position in your application. It can also be misaligned to the dome actuator, reducing the tactile feedback, and can obviously increase rework or production delays. Some common industry challenges that we've seen are low force or low height domes being sensitive to preloading within the overall assembly stackup, harsh environments affecting adhesion or placement integrity, and then there's always the balance of cost, labor, and production output depending on each method. From now, we'll get into each different placement method and overview of each. Starting off, we have the most manual way of placing domes. That's either with tweezers or a vacuum pen. This requires the operator to pick up each dome switch individually and place them, and it's a very manual and tedious process. However, it is by far the simplest. It's the most flexible, and it lends itself to low volume or prototyping scales of production. From there, we have the dart placement pen that we have here. This is a good middle ground. It allows for individual singulation of each dome placement, but it is a lot easier to use rather than a pair of tweezers relative to that. Next, from there, we have our dome on adhesive arrays. Right here, we have a standard dome array, and over here we have a custom dome array. The only difference being that the custom dome array is matched the outline and the placement pattern for the dome switches on your PCB. This is a good middle ground as well, as it offers fast, consistent alignment and ready for immediate assembly. It does have the disadvantage of being limited on repositioning, and this is still a relatively manual operation and not quite suited for automation. Right here in the middle, we have an application fixture that pairs in conjunction with our custom dome array. And this allows the dome array and the PCB to be aligned using the fixture, and that is great, and it reduces human error, maintains alignment and repeatability through the production process. But it requires, obviously, an external fixture to help in that process. From there, as we scale more into automation-focused applications, we have domes that are packaged in tape and reel. These are designed to feed directly into industry-standard pick-and-place machines that will allow turnkey solution right into your already existing automation process. And then finally, not pictured here, but we do have some great information on our YouTube channel. We have a SureShot dome placement robot. It's specially designed to work with our domes, and it is by far the highest speed, most scalable, and most precise automated way of dispensing domes. The obvious disadvantage of that was that there is some programming required in that to suit your specific application, but has the highest throughput of all the options. But with all the overview of all the different methods here, we can move straight into the live demonstration of how each one of these methods work. So starting off with the most basic, we have manually placing dome switches into, we have this kind of demonstration plate here to show kind of how it would be for an operator to place the domes. So here we would start by individually picking up each dome switch and then manually placing it in each pocket. Something to be aware of is that while using tweezers or vacuum pens, it is very easy to accidentally place multiple domes in one location. And then obviously it is a little bit tedious to get these in here manually. So to demonstrate, here you can see it's pretty easy to pick up two by accident and place them without realizing it, because once they're stacked on top of each other, it's fairly easy to miss that there's been two domes placed there. So that's definitely the simplest way of placing domes. Moving from there, we have our dart placement pen. So our dart placement pen uses domes that we package in these aluminum cartridges. The operation is simple enough. You take off the end caps, you place the cartridge inside the dart pen here. That all the domes are stacked neatly and organized on top of the dart. And as simple as pressing this button on the side, you have easy, repeatable, singular placement that ends up being quite a bit faster than just using tweezers or vacuum pen. So that is available as well. From there, we have our simple PMPs, peel and place arrays that have domes pre-mounted on them. And we'll take this mock PCB. You can see all the different dome locations here, and how an operator would use this method is taking the sheet of pre-placed domes on the pressure-sensitive adhesive, taking it off the back, lining the dome switch up with the contact pads on your PCB, and just applying a bit of light pressure to make sure that adhesive bonds. So this is a good way of making sure that your dome is placed accurately and stays in the assembly after it's been placed. The next step above this method is using a custom dome array, in which all the dome positions are already placed on the pressure-sensitive adhesive, matching the PCB pattern. And then they also have these extra features which allow the dome array to be placed on this alignment fixture. You line up the spring-loaded pins with the holes in the dome array, and then you take your PCB with tooling holes included, line those up with its own corresponding pins, and all you have to do is apply some light pressure downward, and that way you're able to place all 18 dome positions in one step. Great for medium-sized volume applications, and great for ensuring repeatable operations in your process. Here we have an example of a larger application fixture with a panelized PCB. Same principle applies though. You have your dome array that gets applied on the corresponding pins, place the PCB on top, and press down, applying some light pressure, and that would then allow you to place every single dome position here in one step as well. So from there, like I mentioned before, we have our Sure Shot placement robot with a great webinar that we've hosted in the past that's great to reference in using that technology. Also, like I mentioned, domes can be packaged in tape and reel so that That way, if you already have automated pick and place equipment in your production setup, it's easy as feeding this in as any other SMT component. From there, we have some basic tips and tricks that I can provide to help with your production and assembly process. Obviously, you'll want to match whatever placement method to your production volume and your PCB complexity. You'll want to choose the adhesive films and arrays or fixtures that balance the flexibility and scalability of your project. You'll always want to ensure proper alignment to the PCB pad as well as the overall assembly to ensure electrical and tactile reliability through the lifetime of the product. And then something to consider is that with an overall stack up, depending on the assembly, the final actuation force with the overall assembly can be a little bit different than the rated actuation force of just the dome by itself. Finally, a really great practice that we always recommend is to ensure that the circuit, the PCB surface itself, is clean and free of any manufacturing oils, dust, or other contamination. This can cause electrical intermittency issues with the dome contacts, or can cause the adhesive itself to not make a proper bond to the PCB surface. From there, we have a pre-submitted list of FAQ questions that we'll run through, but we'll also be inviting questions from the live audience to submit into the chat so that we can address your questions in real time. We'll get right into that then. So Javier from Costal asked, what will be the range in degrees in which a metal dome can be activated in a rotational way to avoid any issues? Typically, we always recommend that the actuation force comes in 90 degrees or perpendicular to the dome surface. However, we realize that's not always the case. From there, it's not exactly easy to provide a one-stop solution answer to that question. However, if you reach out directly to us, we can take a look at your application and the requirements of it, and then we can give you the best guidance from there. So Javier, I encourage you to come to our website and submit an inquiry so that we can review it and get back to you. Vladimir from Costal asks how to select a correct metal dome. So this is obviously a very much it depends question. I like to usually start with an actuation force requirement. From there, we can dive into what the tactile performance or the end user feedback would be ideal for this process. And that would narrow us down usually into a handful of different options. And then we can go into life cycle requirements, plating requirements, electrical performance. All of those are great questions. If you have something specific, like I said, please submit an inquiry on our website. From there, we have Emad from Infusion Innovations. What is the technical justification for requiring a gold-plated surface finish to use these types of switches? Great question, Emad. I'm not sure if you meant gold plating surface on the PCB or gold plating surface on the dome switch. We'll cover both. Typically, the minimum recommended plating style that we recommend is ENIG finish. The benefit of ENIG finish is that it has a very flat surface finish compared to, say, Hazel, for example. We've seen a lot of issues with the lower end plating finishes either wearing away under the friction of the dome through its life cycle, or providing a lot of inconsistency to the tactile feel of the dome. So that's why we recommend ENIG as a minimum surface plating option. And then on the dome side, gold plated finish is great if you want to make sure that you have absolute electrical performance reliability, and usually you have sub 1 ohm contact resistance on gold plated finish like that. Let's see here. Alessandro from Metal asks, best practices for placing SMT domes on a PCB and placing tape over the top? That's a great question. It's something that we've gotten more recently, and I'm glad you asked this. The solderable SMT dome switches that we offer are obviously held down with solder as any other SMT device would be. However, it is still possible to place tape on top of that if you would like that extra assurance for limiting ingress or vibration shock, etc. I would say best practice would be to make sure that following our guidelines, just like any of our normal non-solderable switches, as in using a via hole or some other kind of venting mechanism to make sure that the air under the dome switch has a method to escape and not impact the tactile performance of the switch itself. Great question. Let's see here. Michael asks, improving alignment and repeatability for scale. Well, Michael, I hope that some of these methods were able to answer some of that question, but of course, making sure that a proper tolerance stack-up was done on the design before moving forward is always the best route for that. Adrian from Curtis Wright asks, is the Dart dome placement pen suitable or recommended for automated application? I would say the Dart dome placement pen was absolutely designed for a manual operation, as it has the thumb activated plunger on the side. It's not necessarily designed to be used in an automated setting. We have a counterpart to the Dart, which is called the Arrow. The Arrow is what is used in conjunction with our SureShot placement robot, and that solution is much more tailored to an automation setting. So I would look into the Dart if you're looking, or sorry, into the Arrow if you're looking for an automated solution.
Kyle, I have a question from online.
Okay.
Is there a maximum temperature limit in the surrounding environment, particularly for adhesive domes, that would help prevent movement and or wear deterioration? This is from Ryan.
Good question, Ryan. If memory serves correct, the adhesive that we typically use, it's a acrylic-based adhesive, is rated to 60 degrees Celsius, in ensuring that it maintains its integrity. However, we do have the option to use higher temp adhesives such as polyamide tapes that are better suited for high temperature applications.
And then I have another question from Bill. Are there any reports of intermetallic problems with ENIG PCB finish and the nickel-plated S-series domes?
No, not to my knowledge. As far as our experience goes, all of our internal testing has been done on ENIG with the S-series domes, and we have yet to see a problem with those intermetallic interfaces.
And Kyle, would you mind running through the placement of the dome array again, if you could do another demo of that?
For sure, on the application fixture itself?
Yes, correct.
Perfect, okay, yeah. So here we have that pre-cut and pre-placed dome array. You can see here that we have the 3 pre-cut holes. These 3 pre-cut holes are using these 3 spring-loaded pins in the fixture itself. So the process goes, you peel the dome array off of the paper liner, and then you will align the array with the adhesive side facing up and align the aforementioned cut holes onto the spring-loaded pins. That'll ensure that it lays flat in relation to the fixture itself. Then you'll grab your PCB, also typical to have tooling holes in your PCB. You'll line those holes up with another set of spring-loaded pins on the outside, and that would be the contact side facing downwards. Line that up. They're still not applied together yet because they're offset by a certain amount of space there. So then all you have to do is press downward, applying pressure to the back of the PCB. At that point, you're adhering the dome array to the PCB surface. And then you have all of your domes placed all at one time.
Great, thank you. And just to follow that up, would you elaborate on what the process is for a customer to design a custom fixture for a peel and place array?
Yeah, absolutely. So many times the process where we interface with a customer that have a PCB designed and finalized, they will reach out to us and they will send us a DXF or a step file of their PCB design. We will then design the dome array and the fixture both simultaneously to ensure that they work seamlessly together and mate correctly with the customer's PCB itself.
Great, I got one more question. Do you have a recommendation of tape to be used when the dome is not in an array, just adhering to a PCB board, maybe on a one-off chance?
That's a good question. Typically, we don't recommend having just bare adhesive without it being applied to, in this case, like a polyester liner. That will, in essence, protect the dome from being directly adhered to the PCB surface. You want the tape to be an overlay on top of the dome rather than just have adhesive underneath the dome. Right. We do have some more pre-submitted questions if we want to answer some of those, unless you have more from the live audience.
Go for it. We do have some more coming in though, so.
Okay. Hussein from Ear Technic asks, can we use metal domes in soft plastic injected parts? Yes, we've seen the domes themselves be situated on plastic parts rather than on a PCB surface, especially if this is a tactile only non-electrical switch application. Definitely can be used in that way. We do want to warn that the friction of the dome flexing during its life cycle can potentially scratch the injection molded part itself. So just something to look out for. Let's see here. Angle actuation. Amit from Curtis Wright asks, dome selection and mechanical actuation design guidelines. That's a great question. We get a lot of actuation design questions, and we have a great section in our design guide that you can get from our website. But to sum it up, we typically recommend a cylindrical shaped actuator design that's 20 to 25% of the dome's diameter to match and to ensure that the tactile feel is transferred adequately.
I got a question online. Oh, sorry, Kyle.
Yeah, I just have one last question from Addy from Astro. He asked a great question: how to seal domes without using a vent hole, but keeping good tactile feedback. That's a great question, and we have a solution for that. If you don't want to design a via hole in the PCB itself to vent the air underneath the dome switch, we recommend using a multi-layer dome array design that will keep the tactile performance by venting the air between dome locations. We have a great section on our custom dome array page on our website that has a very great visual representation of what that looks like. So I encourage you to check that out.
This is a question related to soldering. I think it was from Bill before. He said we are using SAC 305 alloy solder, but have also tried 6337 SMPB.
Mm-hmm. Yeah, both of those solder alloys, one SAC 305 being lead-free, and 6337 being leaded alloy. We've done all of our validation testing with our S series using both of those. Either one is a great option.
And to follow up, that he's kind of asking about solder volume. What would be the ideal solder joint reliability for the S-Series domes? Our data sheet says a recommended paste layer is 0.030 inches on the pad size of about 0.059 by 0.035. That seems like that wouldn't provide enough solder for long-term mechanical strength. Would more solder improve reliability or inhibit it?
It's a great question. Our recommended solder stencil thickness is 5 thousandths or 5 mils thick. The actual area of solder we recommend varies from dome size to dome size. On our website, under the pad layouts section, it will lay out each recommended size corresponding to each solder dome size that we offer. We also have our complete pad layout CAD models available on SnapMagic. That's a great way to directly download it and import it into the PCB design software that you're using. Great question.
Is there a max humidity consideration for the heat rating of adhesives?
There is a heat and humidity spec on the adhesives. It does vary from specific thickness to thickness, but I don't know that off the top of my head. We will definitely get back to you on that, though.
John, he had a question. How well does your oblong domes work for wider buttons versus having multiple circular domes underneath?
Yeah, great question, John. We have gone in many times either direction. I think it very much depends on how the overall assembly around it is constructed. If you're using a hard button keycap, a lot of times it's easier to use individual smaller domes so that that force can be transferred directly. However, if you're using a printed graphic membrane switch, then a lot of times it's easier and has a better user feedback by using an oblong dome. So if you have a specific question on your application, feel free to reach out to us directly and we'll provide the recommendation for you.
Can you elaborate on what the suggested tolerance is for positioning the domes on tape, like an array, to the circuit board using a custom fixture?
So our placement tolerances are dictated by basically the flexibility of the tape. As the tape is not a rigid substrate, that's where our tolerance comes from. The standard tolerance for dome on tape is a positional tolerance of plus or minus 15 thousandths. So that is what the repeatability that we get from the fixtures is. It's more dictated by the tape itself and the limitations of the flexibility there rather than the fixture.
Great. And then Greg at Vulture Systems says, we use the individual domes with adhesive squares and we believe we have had some issues with preloaded domes. Can you briefly explain the suggested method of applying?
Right, yeah, great question. So if you're using one of our standard dome arrays where it's a simple pre-placed dome with a square cut tape around it, what you'll typically want to do if you're concerned about preloading is make sure that when you're placing the dome onto the PCB and when you're applying the pressure to fully bond the dome, you don't want to apply a huge amount. You just want to do a light amount of pressure just around the outside, especially to make sure that that adhesive bonds to the PCB. We've noticed that if you specifically apply pressure around the outside of the dome, that helps with any preloading issues, rather than if you straight apply force across the entire area, that can provide some preloading issues.
All right, there's a specific question regarding some specific domes from Sergio at ST Microelectronics. They're using the GX05170 in their board, and they're asking for any suggestions for placing for a board production line.
Okay. Sergio, I am assuming you're looking for a more automated solution. If that's the case, if you're looking at a high volume production line, I would suggest, given ST Microelectronics, I'm sure you guys have a quite robust production line and some good technology at your disposal. I would suggest looking at potentially sourcing the dome arrays in tape and reel packaging. That way you can leverage the equipment that you already have. And if that is not quite the right solution, there's always the Sure Shot placement robot that we can work with you on and get that solution implemented in your production line. Make sure it makes sense for your application.
I think we covered most of the questions, unless anyone has any more. Oh, we just got one more in from Bill again. Do you have any data you can provide on long-term solder joint, reliability, other than the white paper that's on this website?
I'm sure we could. Bill, if you want to reach out and we can work with you on specifically the dome switch that you're looking for and what questions you may have regarding that. However, I can say that all of our long-term accelerated life cycle testing includes the solder joint itself. So if we see a failure in the solder joint itself, that would indicate a failure of the accelerated life cycle test. So just keep in mind when you see the life cycle rating for the dome itself, that includes the solder joint reliability.
Great, thank you. I'm not seeing any other questions come in.
Great. Well, I think we can wrap up with that. I want to thank everybody for attending this webinar today. Hopefully you found it helpful. As a reminder, Snaptron can guide engineers on choosing the right placement method and a lot of other things. So if you have any questions, please feel free to visit snaptron.com and submit an inquiry to us. Contact us on any guidance placing methods and project help for your application. Thank you very much.